Okay, so to conclude chapter 3, we're going to talk about the idea of relative velocities. So let's go to the whiteboard. Okay, so let's suppose you have a rail car. Oh, hold on, I think I want to do that in a different color here. Yeah, so let's suppose you have a rail car. All right. And so this is a part of a train, and it's got the wheels, and it's going on the train tracks. And let's suppose that it's moving horizontally to the right with some velocity. And we're going to call this velocity the velocity of the train with respect to the ground. So that's what these this subscript means. The T part says we're talking about is talking about the velocity of what? It's the velocity of the train, right? This is the part of the train. And then, but it's moving as observed from what place? So this is moving relative to the ground. As observed from the ground, we see the train moving past. And so I'm going to go ahead and also draw a person out here observing the train. And watching the train go by. Okay, and this person lives on the ground. G means the ground, and they're watching the train go by. Okay, and so if you ask this person, hey, what is the velocity of the train? They'll tell you, oh, it's this. Velocity of the train with respect to the ground, right? It's moving relative to the ground to the right with this velocity. That's what the person will tell you. Now let's imagine somebody else who's aboard the train, right? So here's a person who's aboard the train. And so this person is aboard the train and they're actually walking toward the back of the car, right? Let's say this person is walking toward the back, okay? And so if you ask someone who's on the train what this person is doing, right? The person will tell you, oh, you know what? This person in blue is walking toward the back. And you ask them, okay, you're on the train. At what velocity is this person walking to the back of the train with? And they say, oh yeah, the velocity of this person relative to the train is this quantity here. V, the velocity of the person, this is the person P, relative to the train. And so you indicate it like that, okay? So we have the velocity of the person who's on the train relative to the train, right? So this guy is on the train and moving toward the back of the train, right? Got up out of their seat and they're walking toward the back. And but the train itself, as observed from the ground, is moving to the right, like this. And so now it is meaningful to ask, well, from this person's perspective, who's on the ground, what is the velocity of this person who's on the train as observed from the ground? So if you're on the ground and you're watching this happen, you're going to notice that the train is moving to the right, right? Because you see it go by. And let's say that this person can see inside the train, right? Let's say it's got, I don't know, big windows or something. So you can see inside the train and you can see that, hey, there's someone on there who seems to be headed toward the back of the train, right? You'll see both of those things. But the actual motion of this person as viewed from this perspective, wouldn't just be this velocity here. It would be a combination of this velocity and this one. Because as you can imagine, as this person begins to head toward the back, right? You know, some time goes by as they begin to head towards the back, and during that time, the train has moved over to the right. And so this person who's watching this happen, they would see both of those motions superimposed on top of each other. And so this is what we're really talking about when we mean relative velocities. How do you correctly superimpose velocities of things that are moving with respect to each other and also with respect to someone else who's observing them? So the way you do it is quite simple. You simply have to add the vectors. You simply have to add the velocity vectors. So if we are interested in knowing, for example, what is the velocity of the person relative to the ground? Okay, so there's our person, and here's the ground, right? This one here is standing on the ground watching this all happen. And we want to know what is the velocity of this person relative to this ground. So we indicate that as VPG. And it turns out that that simply is going to equal the vector sum of this velocity and this one. So that's going to be the velocity of the person relative to the train, and then you must add the velocity of the train with respect to the ground. You simply add them like this. But now remember, see, this example is intentionally simple so that you can kind of see what's happening. But in general, these vectors that we're adding are not going to necessarily be parallel to each other, right? They're going to be pointing at different directions and so on. And you have to account for that when you do the addition. But fortunately, we've seen in the earlier sections in this chapter exactly how you add vectors together. And so this is no exception. You would simply add the vectors together, and then that would give you the result, the sort of net overall velocity of this person who's on the train as observed by somebody who is on the ground.